This next chapter is all about heat transfer. Basically, the process of either a chemical reaction producing heat or absorbing heat or heat moving from one thing to another. But in order to really understand this, we're going to have to start with energy and the different types of energy that exist. First of all, you'll recall, of course, kinetic, the energy of motion. You'll recall, of course, potential energy. We can talk about a car being at the top of a hill. That's gravitational energy. We can talk about taking a spring and you stretch the spring and it's going to want to snap back to the way it was before. That's elastic potential energy. We can also, and we've done this a little bit when we were talking about chemical bonds, talk about chemical potential energy, in which there is energy that is represented by a chemical bond, and then that can be released. There's also electrical energy, where we've got the movement of electrons, which is a type of kinetic energy, sure, but it's represented in a different way. Since it's the electrons moving, we can take the energy of those electrons and use that to do work. And the important thing for this chapter, we've got thermal energy. This is going to be energy that is represented by heat, energy that we can measure by changes of temperature occurring. So, it is important to keep in mind in this chapter the conservation of energy. You'll recall this as well from previous studies in other classes, just like conservation of matter said that matter cannot be created or destroyed. The conservation of energy tells us the same thing. Energy is not created or destroyed. It just changes from one form to another. For example, when we're generating power, we're going to take coal, for example, and burn it. That's going to release the chemical energy as heat. That heat is going to boil water. That water is going to turn into steam. That steam is going to start moving, kinetic energy. That steam will turn a turbine, a giant fan blade, which will then produce electricity. So now we've got electrical energy. That electricity will move through wires to your home, where you could, for example, power a light bulb. And now we've got heat and radiant energy being produced there. So things just change from one form to another. And you might say, great, that means we could, in theory, make certain devices that would continue to run forever. Because if all energy must be conserved and energy can't disappear, then that means a car should be able to be built efficiently enough that it can just keep running and running and running. Well, unfortunately, friction is always going to take some of that energy and dissipate it. But dissipate it as what? Because it still has to be energy. So think about this for a minute. If friction is acting on a system, what happens to that energy? Let's say kinetic energy, for example. What type of energy will friction change it into? If you're having trouble thinking about this, take two hands and rub them together, and you will feel the production of heat. So, friction's going to take our kinetic energy and change it into heat. Sure, we can develop some devices to gather some of that heat, but a lot of that heat just goes off into the air, vibrating air molecules, and is essentially lost to us. We can't use that form of energy. Another important distinction in this chapter is the difference between temperature and heat. We've talked a lot about temperature this year. Do you remember what we said that temperature was? And we've said that temperature is the average kinetic energy in a substance, in a material. So all those little particles moving around produce a certain amount of what we would consider hot or cold, and that's temperature. Heat, although in the dictionary might have the same definition, in science it's a little bit different. Heat is going to be a transfer of thermal energy, so this energy represented by the hotness or coldness of an object, from one object to another. So technically, heat is just when that energy is being transferred. We can't say that a pot of water on a stove has a lot of heat. It could transfer a lot of heat. It itself is very hot, but it does not contain heat. Heat is the energy in transfer. Heat always flows from the hotter object to the colder object, which may seem rather self-explanatory, but it does lead to some interesting ideas. For example, a freezer does not put coldness into an ice cube to freeze it. The water in the ice cube tray, actually being warmer than the freezer, tries to warm the freezer up, and as a result, lowers its own temperature enough until it is frozen. One last slide for today, heat transfer. There are 3 forms of heat transfer that we need to consider in this class. 3 different ways that heat can move from one place to another. The first is probably the simplest to understand. Conduction. That's direct contact. For example, if you touch a hot coffee mug, your hand will start to warm up. Its temperature will increase. Heat flowed from the coffee cup to your hand, which was cooler. That's conduction, direct contact. Convection. Convection is heat transfer through a fluid. Fluids, you'll recall, could be things like liquids or gases. When a fluid warms up as its temperature increases and those particles start moving faster and faster and faster, they push apart from each other, so their density becomes less, so they rise further up. As they rise up, they cool off, so they move slower, it gets denser, and these things fall down. This is convection. A fluid typically can heat more efficiently than a solid object itself, and we'll take a look at that tomorrow in class. We've also got radiation as a form of heat transfer. Radiation is going to be heat being transferred through electromagnetic waves. So you can probably think of a very common example of radiation heat transfer, a cooking device in your kitchen, a microwave oven. It uses microwaves in order to cook food, in order to transfer energy into the food. So in this diagram up here, you can see conduction occurring, convection here in the fluid, as well as radiation coming off the fire here. We'll review these 3 types of heat transfer tomorrow.